All right, welcome back. So, in the last video, we were talking about histograms, and histograms are really useful for helping us see the overall shape of the data. So the data might be skewed in one way or the other. It might have a bimodal distribution where there are two ranges of values that occur equally as frequently or close to equally as frequently. The data could also have a normal distribution. We saw with that bell shape and symmetric sort of shape in that figure. And histograms are great. They're really good at telling one part of the story. But they don't tell us everything. And so we'll use a box plot to help fill in some of the gaps. Okay, so box plots are very useful in helping us show and helping us see sort of the more intricacies of the data. We're able to see a little bit more with box plots than we are able to see in histograms. Okay, and each have their pros and cons, and each give a certain amount. But there's still a little bit of work that we have to do too. And that's fine. That's okay. So when we're using box plots and when we're making box plots, we have to get comfortable with this idea of a five number summary. So this is a five number summary. Okay. All right. And really all this is just a bunch of more summary statistics that we're going to use to help draw a picture. And I promise you it's not too bad because, well, we're already familiar with this one, this median here. And then the other four, the process is very similar in finding the median, right? Or as finding the median. So let's start there. Let's start with the median. So recall that the median is just telling you where the halfway point is. So all of the numbers below the median represent 50% of the data, and all of the values or all of the data above the median represent the other half, the other 50%, right? Okay, so in another world, right, or in a different class, we would maybe call that the 50th percentile, where all of the values up to the median represent the 50th percentile. Now, let me actually write that out too. Represent the 50th percentile. Okay, so from the smallest value that you have all the way up to the median represents the 50th percentile. That might be familiar to you. You might have heard that in other places, but if it's not familiar, that's okay too. That's totally fine. So the median represents the 50th percentile, that cutoff point where everything below it is makes up 50% of the data. Well, we can get a little bit more granular with that, a little bit more specific regarding other percentiles as well. And we, instead of using percentiles, oftentimes we'll use this fancy word called a quartile. Pretty stupid, I think, but all that represents is just another chunk of the data. Where in this case, quartile 1 represents the 25% mark, where everything below that cutoff point represents 25% of the data. And it's true on the other end too, where quartile 3 represents the cutoff point, where everything below it is 75% of the data. And we see here that we're sort of working in these kind of like quarter increments. Okay, so quartile 1, also known as the 25th percentile, okay, where the median, also known as Q2 if we're trying to be consistent or specific, that represents the 50th percentile, and then Q3, quartile 3, represents the 75th percentile. Okay, and so these are all saying the same thing, right? They're all saying that at this point, it makes up some chunk of the data. Okay, so that's all fine. That's all good. With the minimum and the maximum, there's a small caveat there. So when you see the minimum and when you see the maximum, your sort of immediate thought is to say, okay, that's probably just the absolute smallest number and the absolute biggest number, right, respectively. Well, you would be right if I were asking for the absolute minimum and the absolute maximum. in terms of box plots, what the minimum and the maximum actually denote are excluding the outliers. So outliers, again, are values that are just far away from the next value, right? In English, when we're talking about outliers, oftentimes we mean something that that shows up that's not really supposed to be there, right? It's something out of the norm and it's unusual, right? And so in the case of box plots, right, we sort of adopt that definition of outliers. So for right now, I will ask you specifically for an absolute minimum and then a minimum for the box plot too. And I'll show you a little bit more about that here in just a second. But let's take a look at what a box plot actually looks like. Okay, so here is a pretty basic one with all of the sort of little components outlined here. So we'll start off with the median. We see that the median is just denoted as this, well, I just drew over it, this yellow line here, right here. Okay, and that's our median. Pretty easy to calculate, right? You just line up all the data you have and pick the middle value, which in this case, the median from these data, if we trace this down, is 0. Okay, so all of the values over here make up 50% of the data, and all of the values over here make up the other 50%. So that's cool. That's fine. Let me erase all this, clean it up. Okay. And if we move on, we see that, well, the term box plot really just comes from this idea. There's a big box right here. And all this is really saying is that that's where a big chunk of the data are. Okay. And that's, really, that's really about it, right? So this value here that's that Q1, that's that 25th percentile, okay? So all of the values below this represent 25% of the data. Same thing here with Q3, where if everything below that makes up the 75th percentile, or 75% of the data fall below that value, okay? So that's fine. And if we wanted to kind of estimate what that would be, we would just trace down, and whatever value is right here, let me not put a 0, whatever value is right over here is what that Q1 is. And it's the same story for the Q3. Okay, so that's fine. And then if we come all the way down, we follow this all the way down. This is just saying that there are still some values that fall below this big chunk here, this big chunk of the data. All right. So that's fine. And if we wanted to, we could get very fancy and put each individual point that this represents, right? So there would be a bunch of points in here, too, and then it'd be a little bit further spread out. And then, erase all that, clean it up. We come down here to the quote-unquote minimum, okay? So that's the minimum that are excluding, we see here, these outliers, okay? Excluding outliers. So the true minimum of our data set is here. That's the smallest value that shows up. But that's considered an outlier, and I'll show you the criteria for determining an outlier in just a second. We can kind of get a hint of it right here. But what we see denoted by this line here is the minimum excluding these outliers. Okay, and if we want to figure out what value that is, we would just come down here and trace, and whatever value shows up on the x-axis is our minimum excluding those outliers. Okay, and it's the same story over here too, where this is the cutoff point for the maximum excluding these outliers. And outliers are just denoted as little dots. Okay, little dots. So nothing too crazy there. And then the last thing that I want to talk about is this idea here, this idea of an inner quartile range. Hinted on that earlier, IQR, just a fancy, and it's a stupid term, I think, but it's just a fancy word for saying where a big chunk of the data lie, okay? And that's really that, right? Where about 50% of the data lie. And to calculate that interquartile range, we just take, we take Q3 and subtract Q1. And that's it. That's the interquartile range. And that's what we're seeing over here and over here in these formulas. Now, right now, these formulas might look a little bit weird, but let me show you with an example in just 1 second. So, before we move on, this box plot is perfect. It's totally symmetric. Oftentimes, that is not the case. And we see that here. So this is real data that I've generated, and I've used a box plot to show that data. But oftentimes we see that everything is not as symmetric as we like to see. So the median now here still represents that 50% mark, where half of the data is over here and the other half are over here. But we see that it's not in the exact middle of the box, right? Okay, and over here, still the same deal, right? This line makes up the 25th percentile, so everything below it is 25% of the data. This green line here, on the other end, represents the 75th percentile, so let me write that out. 25%, okay, and then this makes up the 50% mark, all right? And then over here is the 75th percentile, where everything below that makes up 75% of the data. And we see here that it's not as symmetric as we saw in the last figure. We also see now that our minimum value, our minimum over here at the left, is both the minimum excluding outliers and it's the true minimum of our data set. But the story is a little different on the other end. Our maximum over here is a maximum excluding outliers, but we see over here that there's still one outlier way out there, where that denotes the true maximum in our data set. Okay, so over here, maximum with a caveat, and then over here is our maximum, our true maximum. Okay, poorly written. Good Lord. So I'm just so sorry. Okay, so that's our true maximum right here. This is our maximum right here, excluding the outliers. Okay, so that is Boxplots. There's a little bit more work involved, but I promise you it's not too bad. And I'll show you how to do it here with an example right here. But there are some really good formulas that we will use, and you will use on your tests and homeworks and everything, but are just good to know and to have written down. So pause the video, or if you have the PowerPoint up next to you, write these down. Very, very important. Okay, and then we'll get into an example here in just 1 second. So I'll pause the video, maybe review the formulas for the mean and the median, and then these new processes that we have. Nothing too bad, but make sure that you're comfortable with it before we move on. So I'll see you in just a second.